In this slide, we're focusing on a new misconfiguration issue dubbed ALBeast that exposes weaknesses in AWS Application Load Balancer, ALB. Understanding this misconfiguration is integral as it highlights potential vulnerabilities that could impact the security of cloud services. We'll break down what ALBeast is, examine how this misconfiguration occurs, and look at its implications for AWS ALB users. It's important to grasp these aspects to ensure robust security and mitigate risks effectively. In this slide, we're going to provide an overview of the ALBeast vulnerability in AWS Application Load Balancers, ALBs. This vulnerability is a significant security weakness that impacts cloud services, making it essential for us to understand its details. Our main objective here is to comprehend the nature of this vulnerability, assess its potential impact, and explore the steps needed for mitigation. This understanding is crucial for securing our cloud infrastructure and maintaining robust defenses against such threats. AWS Application Load Balancer, or ALB, is a critical component in managing your web traffic. It routes HTTP and HTTPS traffic towards your target applications, ensuring efficient distribution and load management. Additionally, ALB offloads authentication functionality, making it a versatile tool in your infrastructure. Integrating seamlessly with Amazon Cognito, ALB supports various identity providers, including both social and enterprise. This integration allows for streamlined user authentication and identity verification processes, providing robust security measures while handling traffic routing. Understanding the fundamental role of ALB in your architecture sets the stage for comprehending how vulnerabilities could impact your applications and what measures can be taken to mitigate potential risks. Now let's focus on the ALBeast vulnerability. This vulnerability was discovered by MIGO and has quite a significant impact, potentially affecting up to 15,000 applications. It allows attackers to bypass authentication and authorization mechanisms, posing a substantial security risk. The mechanism behind this exploit relies on configuration-based issues within the AWS Application Load Balancer, ALB. Essentially, it takes advantage of misconfigurations, enabling unauthorized access to target applications despite the security measures in place. Understanding the risk and mechanisms of this vulnerability is essential for anyone using AWS ALB to ensure robust security configurations and prevent unauthorized access. Now, let's break down how the attack works. The first step involves the attacker creating their own Application Load Balancer, ALB instance. With this ALB, the attacker can sign a token that they control. After that, they modify the ALB configuration to forge the victim's identity. This allows the attacker to access the target application, completely bypassing its security controls. By exploiting configuration-based issues in the ALB, the attacker can gain unauthorized access, compromising the application's security framework. As we transition into a real-world example, let's explore a scenario involving the exploitation of what is known as ALBeast. Here, the attacker starts by setting up their own ALB instance. They use this instance to sign a JBT token that's under their control. The organization, which is using ALB for authentication, does so without proper configuration. The outcome? The attacker is able to gain unauthorized access to sensitive application data. This highlights the importance of correct ALB configuration to prevent such vulnerabilities. Now, let's move on to examining the tools and techniques that can help you secure your ALB configurations. On this slide, we're focusing on the tools and techniques you can use to work with AWS Application Load Balancers, ALBs, effectively. The AWS command line interface is particularly handy for modifying ALB configurations. For instance, you can use the command bash AWS ALBv2 modify load balancer attributes, load balancer error, attributes, key equal attribute, value. This command allows you to adjust specific attributes of your load balancer, making it more secure or better suited to your needs. Additionally, if you need to list all your ALB instances to get an overview of your infrastructure, you can use bash AWS ALBv2 describe load balancers. These tools are essential for managing your ALB configurations and ensuring that you have full visibility and control over your load balancers. Proper use of these techniques can help prevent unauthorized access and enhance your application's security. When implementing mitigation strategies, there are two key practices to consider. First, always verify the token's JWT signer field before authorization. This ensures that only tokens signed by trusted sources are given access, significantly reducing the risk of unauthorized access. Secondly, restrict traffic by configuring security groups to allow traffic exclusively from trusted ALB instances. By limiting the sources of incoming traffic, you can better protect your application from potential threats and ensure a more secure environment. On this slide, we'll discuss best practices for secure configuration in your systems. Best practice 1. Ensure that your targets accept traffic only from specific ALB instances. This can be achieved by configuring security groups to restrict access accordingly. Best practice 2. Make certain your application properly verifies JWT signatures. This involves checking these signatures to authenticate the token thoroughly. Implementing these best practices is essential to enhance the security and reliability of your applications, minimizing the risk of unauthorized access and potential security breaches. In this slide, we are discussing an update to the AWS documentation as of April 2024. The updated documentation focuses on the authentication feature and includes newly added code to validate the signer field in JSON Web Tokens, JWTs. The key changes emphasize the necessity of verifying JWT signatures, providing explicit instructions to ensure that applications are properly configured to perform this verification. This aligns with the best practice we mentioned earlier about ensuring that applications check JWT signatures to maintain security integrity. It's important to incorporate these updates into your security configurations to stay compliant with the latest AWS guidelines and maintain robust security measures for your applications. On this slide, we're focusing on the shared responsibility model. It's imperative to understand the distinct roles and responsibilities between the customer and AWS. As a customer, you're responsible for implementing secure configurations and regularly updating and reviewing your security practices. This involves being proactive with your security measures, such as setting up proper configurations and ensuring that any changes align with best practices. On the AWS side, their responsibility is to ensure the security of the infrastructure itself. This includes providing updated security documentation, which is key for customers to understand how to maintain their side of the shared responsibility model. Grasping this model is foundational for maintaining a robust security posture in your AWS environment. In this section, we'll discuss some practical application tips to enhance your security measures. For developers, it's essential to implement strict validation on JWT tokens to ensure they haven't been tampered with. Additionally, regularly auditing and updating your security configurations helps in maintaining a robust defense against potential threats. For security teams, monitoring your Application Load Balancer, ALB, configurations is vital to detect any misconfigurations that could lead to security breaches. Performing regular security scans and assessments will help identify vulnerabilities and ensure compliance with the latest security practices. These steps will fortify your applications against common security issues while adhering to the shared responsibility model, where both you and AWS play integral roles in securing the environment. In conclusion, ALBeast is a configuration-based vulnerability, which underscores the importance of careful configuration and continuous monitoring. To mitigate the risks associated with ALBeast, it's essential to follow the guidelines provided by both AWS and MIGO. These steps will help you build a more secure environment and protect against potential threats. In this slide, we provide essential resources related to ALBeast for further reading and understanding. These references include 1. MIGO Research, ALBeast Security Advisory. This document provides an in-depth analysis of the ALBeast vulnerability, detailing the specific risks and recommended mitigation strategies. 2. AWS Documentation, Amazon ALB Authentication. AWS's official documentation will guide you on configuring and securing your application load balancers, helping you follow best practices. 3. Hacker News Article, New ALBeast Vulnerability Exposes AWS ALB. This article sheds light on the latest discoveries related to the ALBeast vulnerability and the broader implications for AWS ALBs. These resources are critical for staying informed and implementing the necessary precautions in your environment. Make sure to review these documents to strengthen your understanding and enhance your security posture. Let's now move into our Q&A session, where we can address any queries you may have. Here are a couple of questions to keep in mind as we proceed. Firstly, have you reviewed your Application Load Balancer (ALB) configurations recently? Given the recent security advisories and updates, it's important to ensure your settings are optimized for the best possible security. Secondly, are you fully aware of the specifics of the shared responsibility model for your deployment? Understanding what you're responsible for versus what AWS handles can help prevent security oversights. Feel free to bring up any other concerns or questions you might have regarding ALB security configurations and best practices. Stay vigilant with your AWS Application Load Balancer configurations. Regularly audit them to ensure they align with the latest security standards. It's essential to stay informed about the latest vulnerability disclosures, which can help you stay one step ahead of potential threats. Moving forward, it's important to implement the recommended security best practices. Engaging with security advisories and updates will also keep your systems secure and resilient. Continue enhancing your understanding through further reading on security best practices, advances in cloud security, and token-based authentication mechanisms. For those looking to expand their knowledge further, this slide highlights some valuable resources for continued learning. First, AWS Security Best Practices is a comprehensive guide that can help you understand the most effective strategies for securing your AWS environment. Advances in cloud security will provide insights into the latest developments and innovations in cloud security, ensuring you stay current with modern methods and technologies. Lastly, token-based authentication mechanisms is essential reading to thoroughly understand this key aspect of security, especially in today's distributed and service-oriented architectures. These resources are instrumental in deepening your understanding and ensuring robust security practices in your cloud infrastructure.